Hi, hello everybody. So this is the video where we talked about section 4.6, graphs of other trigonometric functions. And so this topic has two parts. The first part is the tangent function, and the other is the cotangent. Those are the only ones we're going to be seeing in section 4.6. Now, as you see here, the graph of the tangent function looks like this. And since it's a periodic function, every piece of the period is going to look the same. So we're only going to be graphing one period of the function. So in the case of the basic function, which is tangent x, the period is pi. And we're going to be graphing three pieces of it. The x-intercept, which is location in here, where the tangent crosses the x-axis, and the vertical asymptote to the right, and the vertical asymptote to the left. Now, so if you remember, asymptotes are these dashed lines that the graph gets closer to, but never crosses or touches the vertical asymptote. So it's the same for both sides. Okay. The graph is approaching and approaching, but never touches and never crosses that location. So only 3 points, the two vertical asymptotes and the x-intercept in the middle. Now, the basic format of our tangent will look like this right here. Okay. We're going to have a value multiplying the tangent. We're not really interested in the size of the stretch or the shrink, but just if it's positive or negative, because we can't really see on the graph itself, even if we had a software to do it. So we're only interested in if it's positive. If it is positive, the tangent will look like this. If it's negative, it would be a reflection on the x-axis, and the tangent would look like this. Okay? So we're going to be doing that. We'll plot the x-intercept, and I'll show you how to do that. And then we're going to find the two asymptotes. We'll plot them into a dashed line format. And that would be it, only these 3 points. We're not going to find any additional points because it's just almost impossible to see what they look like on the graph itself. All right, so let me show you how this is done. So I have 3 examples here. Okay. Just move this maybe over here. I have 3 examples, and once you do one, everything is the same. Okay, so let's do the first one. So we have to determine the value of A as if it's positive or negative. In this case, obviously, there's an invisible one here, so it's positive. So the tangent is exactly the same as you've seen before. So this is even before we have any points, we're going to graph the tangent immediately. So here's going to be my x-intercept. And because A is positive, we'll graph the tangent. Now, you have to graph a line that is approaching the asymptote. So the dashed line is the asymptote. So on the right side, it will look like this. And on the right side, I'm sorry, on the right side, it would look like that. And then on the left side, it would look like this. Now, all that we need now is the equation of the asymptote to the left, the asymptote to the right, and the x-intercept right here. So now let's do the x-intercept first. So the x-intercept is you're going to get the information within the parentheses, and you're going to make it equal to 0. And then you're just going to solve that for x. Okay? In this case, it's just minus pi over 2 on both sides. And we get that x is pi over 2. I'm sorry, negative pi over 2. Okay, just a second. So the location of the x-intercept will be negative pi over 2 comma 0. Okay, We're not going to be doing any shifts up or down, right or left, just the standard function in this format. Okay, so the x-intercept is pretty easy, and it's always done the same way. Now, for the two asymptotes to the right or to the left, now the period of the tangent is pi, and it's half a pi to the left, half a pi to the right. So for the vertical asymptotes, we're going to solve two equations. The first one would be this information that is inside the parentheses equals negative pi over 2. That's the vertical asymptote to the left. And the other one would be pi over 2, which is the vertical asymptote to the right. And then we're going to solve both them separately, and we're going to find the location of the asymptote. So as before, I need to solve for x. So minus pi over 2 on both sides. Obviously, here they cancel, and I end up with minus pi over 2 minus pi over 2 is minus 2 pi over 2, which is obviously minus pi. Okay, so this is the location of the asymptote to the left. Okay. And the one on the right, same thing. Solve that equation, minus pi over 2 minus pi over 2. They cancel here, and I get pi over 2 minus pi over 2, 0. So this is the asymptote to the right. So once we get the two asymptotes and the x-intercept, we graph the tangent as you see here. You can graph it before or after, it doesn't really matter, because the only thing that's going to be different are going to be these 3 points or these 3 locations on the graph. So this is the first example. The other ones are exactly the same. Let's go over the next problem. Obviously, if you need more time to digest some information or check it, you can always stop the video. Second example, notice now that I have a equals to 2. So this will be a dilation, but on the graph itself, it's very, very hard to see, even with software. So again, we're only interested in the fact that a is positive. In this case, a would be negative, and there would be a reflection on the x-axis, which we'll see later. So same tangent. So immediately I can already graph. I'm going to put a point here in the middle of the two asymptotes, and I'm going to graph a standard tangent. Okay. And all I need now are the two asymptotes and the x-intercept. All right, so the x-intercept, same as before. I am going to get the information inside the parentheses, and I'm going to make it equal to 0. And I'm going to solve for x. Okay, so I'm going to multiply both sides by 12 to get rid of the denominator. So I have 12x over 3 for x plus 12 pi over 12 equals 12 times 0. Okay, so now minus pi on both sides for x minus pi, and divide everything by 4, and we get the x is negative pi over 4. So the location of on the x-axis here, the x-intercept is negative pi over 4, comma 0. Okay. And all I need to do now is find the two asymptotes. All right. So for the asymptotes, I am going to do, you get the information inside the parentheses, which is x over 3 plus pi over 12. And you're going to make it equal to negative pi over 2, which is the asymptote to the left, and then pi over 2, which is the asymptote to the right. Okay, let's do the negative pi over 2 first. So again, I'm going to multiply everything by 12. So, and this is going to multiply here, here, and there. Right, so 12x over 3 again is my 4x. 12 pi over 12 is just pi, and 12 times negative pi is negative 12 pi over 2, negative 6 pi. Now solve for x, minus pi on both sides. I get 4x equals negative 7 pi, and then divide everything by 4. We get that negative 7 pi over 4. Okay, now this is the asymptote to the left. So here is, you would write 7 pi over 4. Now, to do the other one, all I have to do, I'm going to erase this. All I have to do is change this to pi over 2, because that would be where the other asymptote would be. So, same as before, multiply everything by 12. So I have 12x over 3, 4x, 12 pi over 12 pi, and 12 pi over 2, 6 pi. Minus pi on both sides. I have 4x equals 5 pi. Divide everything by 4, and we get 5 pi over 4. That is the asymptote to the right. So 5 pi over 4. Okay, so we got the two asymptotes, and we got the x-intercept. We graphed the tangent, and we're done. Now, let me show you once, confirming that this, I'm only going to show you one example, that this value is the correct value of the asymptote. Now, the tangent does not exist at 90 degrees, right? There is no tangent at 90 degrees. You can check this with your calculator. I'm not going to check it now, but I'm going to show you that this is the case. Okay, so let me just erase all of this information right here. And this is a check that the asymptote is correct. Now, if that's correct, then when we replace this value with 5 pi over 4, so I'm going to write it here. When this is 5 pi over 4, this should be equal to 90 degrees, right? Because if it is, then that means that the graph is approaching infinity, and this is an asymptote. So let's check. So I'm going to replace that x with 5 pi over 4. And I'm going to confirm that this is 90 degrees. Obviously, 90 degrees is pi over 2. Okay, so the first fraction, I'm going to multiply by the reciprocal. So 5 pi over 4 times 1 over 3 plus pi over 12. And obviously, this is 5 pi over 12, 4 times 3. And obviously, pi over 12. And obviously, this is 6 pi over 12, which is pi over 2, which is the 90 degrees. So this value, pi over 4, is correct. The minus 7 pi over 4 is also correct, but you could check it, confirming it is correct. Okay, now let's check the last case. The last example I have is one that has a minus. So the minus is, as we've seen before on the transformations, so A is negative, which is a reflection on the x-axis. So when you graph your tangent, instead of graphing the normal way, the piece on the left side of the tangent is going toward positive infinity, and the one on the right is going toward negative infinity. So this is what the graph should look like on a minus tangent. The x-intercept and the asymptotes we find it the same way. So I'm going to get 2x minus 2 pi over 3 equals 0. And I'm going to solve this for x. So I'm going to multiply everything by 3. to get rid of the denominator. So I have 6x minus, this is 6 pi over 3, which is 2 pi equals 0. So now I add 2 pi to both sides. And divide everything by 6. So this is always simplify the fraction. Okay, so this is pi over 3. So the x-intercept has coordinates pi over 3 comma 0. Remember, since we're not doing any shifts up, down, right, or left, the y coordinate is always going to be 0. So this is my x-intercept. Great. Now I have to find the location of the two asymptotes. Okay. Now for the one on the left, you're going to get the center information inside the parentheses, and you're going to make it equal to negative pi over 2. And we're going to solve this for x, right? So just as before, to get rid of the denominator, I'm going to multiply both sides by 3. So the 3 is going to distribute here and there. So I have 6x minus 6 pi over 3, which is just 2 pi. And this is negative 3 pi over 2. I guess we could multiply, instead of multiplying by 3, we could multiply by 6. Can do that. But since I'm here right now, so I'm going to add 2 pi to both sides. Okay, I'm going to have 6x equals, so now I have 2 pi minus 3 pi over 2. Now find the common denominator, which is 2, which means that you have to adjust the numerator here, 2. Now, I'm not reviewing addition or subtraction of fractions. If you need to review something, you just Google this for a couple of minutes, and then you review how to find a common denominator. So this will be 6x equals 4 pi over 2 minus 3 pi over 2. Obviously, pi over 2. So 6x equals pi over 2. And now divide everything by 6, right? And we get pi over 12. So this is the one on the left, right? Here's your minus pi over 2. This asymptote is the one on the left. Now, so ignore the fact this is not the origin 0, 0, okay? So this is just here because I wanted to show you the axis, okay? Now, how do we find the right asymptote? So the right asymptote, instead of, and I'm going to erase all of this again so I can write it over here. The right asymptote is you're going to get the information inside the parentheses, which is x over 3 plus pi over 12. I'm sorry, not that one, right? So we're on the third example. We're going to get 2x minus 2 pi over 3 equals pi over 2. So in the left asymptote, we're going to replace this, right? We're going to make it equal to this. On the right asymptote, we're going to make it equal to pi over 2. So here it is. And now I'm going to multiply both sides by 6 to get rid of the denominator. So I have 12x minus 12 pi over 3, which is 4 pi, equals 6 pi over 2, which is 3 pi. And I'm solving for x, so I'm going to add 4 pi to both sides. So I have 12x equals 7 pi, and then divide everything by 12. Okay, so that way you don't have to deal with adding or subtracting fractions with finding the LCD. Okay, so this is 7 pi over 12, and this is the location of my other asymptote, 7 pi over 12. Now remember, this is a vertical asymptote, so the equation is always x equals, okay? So make sure that you write that on the exam. So once you have all of these 3 points and the two asymptotes and the x-intercept, you're done with the graph. Okay, so this is all that we need to do when graphing tangents, the two asymptotes and the x-intercept. And you're going to do it the exact same way we did. We don't need any middle points between the x-intercept and the asymptotes.